This is a talk about web services and native code, so you can check your boarding passes if you're just to make sure that you're on the right flight. We're going to fly for an hour, 15 minutes, roughly. Thank you all for coming. My name is Nicola Duder. I'm a program manager from Microsoft. And we'll be talking about web services and native code. I see still people coming into the room, so I will start with a brief story, kind of to help you understand why we're talking about web services and native code. If you try to build a web service right now, today, or a consumer to web service, and you will start looking for a technological solution to do that, Windows Communication Foundation is going to be most likely the advice that you will get and most likely the technology that you will use. It's a great technology. It works excellent for this task, and it was built specifically for this task. There is only one caveat to using the WCF. It introduces the managed code into your product, into your application. Now, this could be acceptable for most of the applications. It could be not acceptable for some applications for many reasons. Primarily, it could be, that this could be a legacy code, native code in the process. Then if you build in the web service on a WCF, that asks you for an interrupt layer. How you're going to organize interrupt layer. There are many technical solutions to do that. You can COM interrupt, p-invoke, C++ CLI-based interrupt. All of those are not simple. They're actually asking for quite advanced understanding of the two worlds, both the world of native code and the world of the managed code. And there wasn't a solution before offered by Microsoft for this task in the native code. There were several technologies around for some time, things like ATL Server, SOAP Toolkit. The issue with those is that they haven't been updated for roughly 5-6 years, when the web services world, with all the standards and all the protocols, has been quickly moving to new protocols, new specifications, new standards. And if you try to choose any of those tools and build a consumer or service that is interoperable with, let's say, WCF service on another side, unfortunately, it is not going to work. The good news, that was the story of yesterday. Today I'm here to present interoperable solution to this task. The name of it is Windows Web Services API. And there are key parts of this name, web services in Windows, and so I will speak for each of those. The task, as I mentioned for this, is to connect native code to web services. And because we're connecting the native code, there is no dependency on .NET Framework. Because this is a part of Windows, it's a flat C APIs, similar to all other Windows 32 APIs, with C structures for the key types, and C types overall, and functions for all the conceptual operations that you can do with API. You can both build the consumers to web services, and you can build the web services itself. Another main part is that it's interoperable with all SOAP stacks that implement WS star protocols, web services protocols. We work hard to make sure that it's interoperable with WCF for majority of the scenarios that we support in the V1 release. I will actually briefly talk about where we do not overlap with WCF and what's the future plans. ASP.NET XML Web Services. This is basically, those of you who are familiar with WCF, this is basically a HTTP profile with some security. And other non-Microsoft stacks. I'm not sure if the audience is aware, there are events on Microsoft campus called PlugFest, where all major SOAP stack providers come together and test interoperability. We've been participating in those for about 2 of those before. We're going to participate going forward, actually. Right after the conference, we're going to one that is around the testing basic profile, interop, and other events like that. Now, you may probably guess from the title of the talk on the handout that it's part of the Windows 7. And that's correct. It's in Windows 7 on all SKUs and on server and client versions and on all kind of standard and pro, whatever we have, like, as for the actual version of the Windows. However, we do understand that you need that similar support on all other versions of Windows. Thank you, guys. We're working hard to make sure that around Windows 7 beta, there will be system update, beta version of the system update for you to deploy to XP, Vista, Windows Server 2003, Windows Server 2008. And then once the RTM of Windows 7 ships, we will make sure there is an RTM for the same update. The reason why we do after the Windows 7 deadlines, because we pretty much, it's from the engineering standpoint, we ship the version in Windows 7. Then we take kind of the same source code snapshot. We rebuild the XP and all of the versions in different locales, package them, put them on a website with appropriate EULA and everything, something that for you to download. I see I have a question. Let's take all the questions in the end. No Win2K. There was a question whether we support Win2K. No, there is not going to be Win2K. This is the current plan. We can talk offline about whether you need it. I'm asking to hold the questions to the end because actually I had a bad cold for the whole week, and I'm not sure how long my voice is going to last. So please hold the questions till then. I just kind of at least want to go through all demos with you and all slides, and hopefully my voice will stand with me. So what are we going to do for the rest of the talk? For the rest of the talk, we're going to talk about the conceptual parts of the API. I have about 4 demos to show you all kind of 4 conceptual parts of the API. And that's about what we will do for the rest of the talk. And then we should have plenty of time for your questions. But I think I expect at least 15 minutes for your questions. Before we do that, I wasn't sure how many people will know the key parts of the web services and overall, like, familiar with web service. I'll spend about a minute or 2 on a very quick refresher of key parts of the kind of building web services and consumer, just to make sure that as we go through the demos, everybody's on the same page about why I do what I do. So let's do very quick. For those of you who know everything of that, just bear with me. It should be very quick. Okay, so what is a web service? Okay, so in the world of web services, there is a web service, and there is the consumer's client to it. Okay, a web service is usually a set of endpoints. Every endpoint implements some kind of functionality, so this is some kind of resource. Okay, client is going to send messages to web service. Web service is going to send replies. So this is kind of basic things. Client has to pick which endpoint the client is going to talk to. So that's why I'm saying that's why you see endpoint. Some endpoint that client has picked and decided I'm going to work with that endpoint. It could be several, but let's focus on a simple case. There is one endpoint that client is talking to. Now, there are 3 parts, ABCs, that define endpoint, and client has to choose that. One of them is address. Okay, so it's the actual physical address to where it talks. The binding, that's a set of rules about how you communicate it, which transport, which addressing, and all those things. Okay? So binding, B. C is a contract, and contract actually has 3 parts. It's a service contract, actually the list of operations of the web service. What you can do, think of this as the methods on interface. And then there is data contract, is actually about the types. What types you can use with this interface. And then you have a message contract. What could be the part of the message? What could be the headers, and what could be the part of the body? Okay, so ABCs. So we will see that in a demo. I will tell you we're going to use here's we set in the address, here's we set in the buttons, here's we set in the contract, and stuff like that. There are usually 2 objects that kind of manage communication. Okay, on a web service side, there is usually a service host. Those of you who are familiar with WCF, that's actually the actual name they're using. There are similar names in all other SOAP frameworks. This is the object that helps with accepting messages from the clients, dispatching them correctly, and all the other things. On the client, there is usually proxy, a stub, a service proxy. In the world of WCF, we actually use the same name. It does the same thing. It makes sure that messages right correctly formatted before they're sent to and everything like that. In between there are WSDL and XSD. Remember that we're talking about SOAP web services in this release. So we're talking about WSDL and XSD. We're not talking about REST in this point yet. We will actually discuss this a little better when we have Q&A session. So in every WSDL and XSD, also called like metadata, they help with definition. They help with creation, client, like consumer, or they actually help with creation, define the service. So that's kind of the service host, or like service will usually publish it, or it uses to build the service, and client actually will also need to get those, download from the running source, and actually it helps him with generating the proxy. So there's usually a tool in all SOAP frameworks that is code generator. It goes through the metadata and generates the code that you're going to use. Every SOAP framework has something like that. WCF code has SVC util. Those of you familiar with ATL server, this is GSOAP as proxy. There is GSOAP. Those of you who are familiar with GSOAP, and many other things. Okay, so this is the refresher, very quick. Again, the point why I mentioned this is that because in the demos, I will show you these parts. Okay, I will show you the ABCs, how you set ABC on a client, what is the service proxy, what it does. We will talk about this with the XSD, how you run code generator to get the code that you need. Okay, so we're done. We're now moving to actually first demo, and before that, we will talk about what is the conceptual parts of this new API set. So here's the picture. And I will speak for this picture, and then we'll drill down into every big bucket that you see on the picture. Now, except two, I guess. Your application code, it's your application code. You see this on the top. Network I/O. This is actually the protocol stacks that we're using in our implementation. Things like WinHTTP, if we're talking about HTTP channel, HTTP/sys, if this is on the server, WinSock, and things like that. You don't need to access those. You can. It's up to you if you have to do something specific in your application. But overall, if you're using the APIs, those things are hidden from you. You have full access to them from our API. So let's talk about conceptual kind of parts of the API. Those of you who are familiar with Windows Communication Foundation, you will see the familiar terms, and they actually have similar meaning. Service model is a top level API. It's about having strong types, kind of. So it's about making sure that as you work with web services, you're actually working with the C functions, C callbacks, and C types. And you don't actually, that's the interface that you need to work with. You don't need to know what is headers and bodies and XML message, SOAP, and stuff like that. You're only working with the C types, C functions. So this is top level. We expect majority of our customers, majority of you using service model. And it actually gives you access to all other parts of the API set. Channel layer is about the full control. That's actually where you are asked to step into the world of web services. Okay, you ask to understand what is a channel, what is the message, how the message is sent, when it's sent, what is the body of this, what is the security description, what is the right binding, what is the right channel, stuff like that. I will talk about this. XML layer is actually about, it's up to you. It's up to application code how the messages are sent and everything. It's about formatting the messages. It's about serialization. And again, we'll talk about this in detail. It's actually the next slides. Three vertical bars. Those are helpers. There's actually several of them in our API set. These are the most kind of that you are most likely to see or most likely to use. And again, if you're familiar with WCL, they actually have the similar meaning. Async context is about whether you're calling the APIs or operation of the web service synchronously or asynchronously from different threads and things like that. Heap. Heap is about helping you to avoid complex allocation, deallocation pattern that usually asked by C APIs that you're using. We actually, I will show you, and we have this in a fourth demo. I will show you actually how, what is the value of heap to you, and I will actually mention other things. And errors is about them giving you the rich error information. I will again show you in the second demo, but how, we pretty much giving you like a call stack of what is the root cause of the error. So false will be also there, and other things. So false are the errors in the web service world. So if you service didn't like the message from the client, consumer, it will send back a so false saying, I don't like it. Deal with it. Okay, so before the demo, let's talk about service model. This is the top level. Just to reiterate, just to mention what is service model. So let's just focus on the service model, and then we immediately jump to the demo. So service model, again, it's about automatically managing communication for you. Okay, so you remember the web services refresher slide, service proxy, service host. Yes, we have those two objects. They do actually what they're supposed to do in terms of what they are supposed to do in the world of web services. They help you with communicating to another party, formatting the messages, and other things like that. As I mentioned before, the message exchange, when you're using the service model APIs, is about function calls. You're pretty much working with C APIs. And clients will call generated functions, which map to operations on a remote web service. Web service is going to implement the callbacks that service host is going to call once it gets the request from the client. And then you get the request from the client, service host call you, did the operation, you provided response back to the client. We will focus on the client side in the demos. There are actually plenty of about 50 examples in Windows SDK of building the service side. There's overall about 92 examples in a Windows SDK, and 50 of those is about service. So we'll focus on the client just to keep it simple in this part of the demo. Because service model is usually driven from the contract, from the metadata, there is a tool, it's called WCTL, Web Services Tool, similar to SVC util, sproxy. This tool will go through WSDL and XSD, generate all C structures and functions that you need in order to achieve your goals in terms of the work with APIs, in terms of build a client or build the service. Okay, so we're in a demo, and I will switch to my laptop. So I'm running Visual Studio 2008 SP1 on Windows 7 M3 build with Windows 7 SDK. It didn't crash in all the practice of these talks, but just in case, that's why I have the second laptop on the stage. It's set up exactly as the first one. So if we observe the crash, I will move to another laptop. Okay, so can you see that? Okay, so here's the setup. We're talking to WCF web service. I took it straight from the WCF samples. Okay, this is a calculator service. This is the classic example. If those of you who attended PDC 2005, you probably saw that in every talk on WCF. This is that service. Okay, calculator, add, subtract, divide, and multiply operations on it. And here it is deployed on my local host. So we don't need to wait, for the connection for network, because that's not the point of the demo. This is the Visual Studio. I will make sure that this is the Visual Studio project, actually the same sample. I just added a C++ project, console app into it. And we will work on this C++ project. So I've done several things before just to save the time in this talk. So let's look on what I've done. I run SVC util. This is service tool from WCF. And I download the metadata from running service. What it basically did is actually, you can see it generated 4 files for me. Here they are. It generated 2 WSDL files and 2 XSD files. You can actually have, depending on what technology you're using for the service, it could be just 1 WSDL. It could be 6 XSD files, could be 3 WSDL files. It depends. Now, in this case, it's just 2 WSDL files, 2 XSD files. The next thing that I've done is that I run the wctil. Here it is. And I just provided these all files to the tool. Now, this is the M3 build. So that's why I kind of use the long command. The first switch, it says the policy, it says actually go through the WSDL file and figure out the binding information that is saved in the policy part of that WSDL. And then you just provide the WSDL and XSD file. If when you get the beta builds, because I already have the beta builds, this is how you will run the same command as soon as I switch off the caps lock. wctil.exe, and you will just start that store in the folder, assuming that you don't have any other files in that folder. Or if you have others, then of course, yes, provide wctil.xsd. Okay. Or use the same command if you have many WSDL and XSD files you just want to run on several of those. Okay, so still with me so far? 2 tools. One is download the metadata, wctil, then to go through the WSDL files. Now let's look on the project. So, and we'll switch into the full screen mode, so don't worry. You will see a lot of code. What I've done then, I added every file that is generated, and it's generated pretty much 2 files per every file in metadata. So we had like 4 files, 2 WSDLs, 2 XSD. It generated a header and a C file for each of those. So here they are. I just add them all, and that's about it. So let's switch to the full screen mode. And here's another thing. What I've done, and this is I started with an empty empty main CPP, and what I've done is I included the first file. This is the all APIs. So this is pretty much what you will have to do. This is webservices.h. It comes within the Windows SDK. Also, I went to the project settings and I add webservices.lib as an import library. Okay. And then I included all the headers that are generated. Usually, the trick is include all the XSDs because they are the types, and then include WSDL files because they are operations, and that are using those types. That's kind of I will give you a tip. So I created then error in a heap. They are not the main thing for this demo, and I will show you, as I said, we will see the value of error in the demo 2 and the value of heap in the demo 4. I will show you those. Just for now, we're just using them. So we will focus on, in this demo, we'll focus on ABCs. How do you set, how do you find the binding information? How do you find the contract, or elements of contract that you're looking for? And how do you find the address information? Okay. So let's start with the contract. So let's say I want to call operation multiply on this web service. How do I find it? The trick is you go into the generated headers, and what I usually do, I look for the name of this command. There are actually comments, so feel free to look into the comments once you generate the header first time. It actually speaks for everything that I'm going to kind of show you during that. But here's basically, so let's say I want to find multiply. Okay? Oops, just because it's on the top. Hold on. Well, why? Hold on. Yes, probably. I know what's going on. I know what's going on. Yeah. Much case and much whole world. Sorry. I was doing something else on this demo before. Okay, here it is. So basically, it actually says, so if you read the comment, it actually says, the following client functions were generated. This is the functions that you can use on a client to talk to the web service. And if I click next one, this is actually the prototype for you to use. So actually, this is the functions that you will need to call on a client side. So we'll just copy in. So what I usually do, I just copy and paste into my source code. Here it is. And then I will just fill it out. So HR, I already created the HR. Now this will be, that's actually we will be creating. So this is actually our contract. Okay, we found actually this element of the service contract that we use. Because this is the input types, the basic types. So this is actually elements of the data contract. And we will not look into the message contract at this point. So we have the heap. So I will just say no heap. Call properties. Call properties are helpful if you, in some advanced scenarios, we are working on a basic scenario, so we will just say we're not going to pass any call properties. Async context, I mentioned this. It's about whether you want to call it synchronously or not. No, I don't. I just want to call synchronously. It's a basic scenario. And now we have. So what do we basically need? We need this input data. Okay, and we will do that in a minute. And we need to create service proxy to set the address, and we need to set it the binding. So that's what we do. Okay, so let's do the input data. It's simpler. So N1, I don't know, I'm just making up some values. N2, and we need multiply results. Okay. So service proxy is where you need to set the address and where you need to set the binding. We start with the binding. Binding is the more core piece that you need to do first. And in a place where you do this is when you create the service proxy. We kind of declarative model. When you create the service proxy, you need to say what binding the service proxy object is going to use. There are two ways of doing this, one harder way and one simpler way. We expect you to use the simpler way, and I will show you the simpler way. And then in the next demos, I will show you the harder ways and how kind of show you the problems with the harder ways. So let's do the simple way. The simple way is to use the pre-generated helper. And we go back to the header file. And if I look higher in the header, I will find this, again, this is the stub that is generated for me. Because the WCTL analyzed the policy. Remember, I passed the switch policy. It analyzed it, and it looked through the binding information, and it generated me this helper that I can going to use to create the service proxy. So again, I usually just copy and paste that. And I will just fill it out. Template. This is M3 build. So what you need to do in an M3 build is just usually declare an empty element. In beta builds, we already modify this. And unless you actually need to provide some information in the template, there are cases like, for example, you need to provide maybe like client credentials for authentication. Then you need to fill it in. But in all other cases, you don't. Actually, in a demo 3, I will kind of speak a little bit about this more. So what I usually do is just, I just fill in an empty template. Proxy properties. It's about settings like callbacks and all other parameters of proxy. This is the basic scenario. We don't need to do any of that. So just now, there are a rich set of properties you can set, but not in this demo. We don't need to do this. This is actually service project monitor, so that's where it's going to be created. And this is the error for error information. So this is our binding. This is as far as you can need to know about the binding if you're using the service model. As you can see, actually, because this is WCF service, it's actually recognized that it's basic HTTP binding, that if you are familiar with WCF, you know what that is. And this is service. This is interface al calculator, again, because of the WCF service. And same like you see, this is the similar on like this method, because this is called an operation multiply on an interface al calculator on basic HTTP binding. And we will see WES HTTP binding in the next demo. Okay, so this is, I created the service proxy. Now the next question, so we have contract, we have binding. Now address. How do we select the address? The address you do it when you open it. That's where you open a service proxy, you tell it, I'm going to use that service proxy with this specific endpoint that sits on this address. So the way how you do this is, you do open service proxy. And the first parameter is actual service proxy. The second one is the address. So this is going to be the structure. I will just for now fill it in, and I will create it later on. No, I want to have this synchronously, and yes, I will. Here's the error object. We're not going to use it in this demo, but we'll just pass it. So address. So the name of the structure is the WS endpoint address. And it has element URL. Here it is. So IntelliSense is helpful. It says that this is a type WS string. String I didn't mention on the slide is just a type that we're using. It's a counted string that we're using internally. So we don't, it's not non-null terminated string. It's just counted string. So it's basically a structure which has the length of it and then array of characters. It helps with our performance, so that's why we're using it. Okay, so this is actually a placeholder, and here's the actual string. There is a helpful macro, WSTring value, and it helps us with creating this string. So I need to go back to Internet Explorer. I will just copy the URI. Here it is. Now that's it. Now the only thing that is missing here is some kind of error handling code. Okay, so we'll just quickly add this. And what do we have? We actually will just copy and paste it from previous code. Our samples actually using go to kind of like, if something happened, we just go to the section, and then clean everything up. But I don't use it here, so we pretty much need to kind of roll back saying, okay, we allocated heap before the service proxy, so we will free heap here. And if we try to open a service proxy and it fails, well, then we need to free service proxy. Okay. Now, we call the operation, so we probably want to see some results. So we will actually use another helpful macro. If it succeeded, we're going to print it. Let's print something like, f multiplied, double multiplied by another double is third double. And 1 and 2 result. And if it failed, then it's failed. I just print out that it's failed. And we will maybe debug it a little bit. But hopefully it won't. So we already freeing the heap in error. So we just need to close the service proxy because we open it. And on HTTP's channel, actually, it will always close. On a TCP channel, actually, it can be waiting for some last transactions. So that's why, in addition to service proxy, you pass in asynchronous context, meaning that whether you implemented the callback and you want to wait for it to close in service proxy. But in this case, no, I'm not. And so that's it. So just to reiterate, so what we've done. This is the part of the contract. We copied this from the generator header. This is the operation that we want to call. If there was another operation, there would be another method that we want to call. We set the input values that we want to do. We declared the output. We opened the service proxy where we set the address. And we create the service proxy, and that's where we use the binding information. So, well, let's try building it. Let's see how many errors we get. It's a C code, so. No, I mean, I didn't get an error. Wow, surprising. OK. Those of you who have calculator can verify. I hope WCF service is doing this operation. So that's what it is. So what we learned, this is a very basic kind of example. But as you can see is that basically, I hope you saw the programming model. This is C APIs, C structures, C types. You didn't see any WSDL, and I didn't show you because you don't need to know that. I mean, I only run the tool on it. And you didn't know about what headers to set and what is the binding and what protocols this using and all other things. And that's the whole purpose of Service Model API. You need to know C, okay? And that's about it. And that enables you to talk to web services. I didn't show the service side, but it will be pretty much the same. You will implement the callbacks. So there will be actually in a header, there are, here's these callbacks. Add callback. This is the callback that you will implement. Basically, I think if you know C, you know how to implement the callback. So I'm not going to show that. Let's move on with the slides. Actually, I need to switch to. Okay, so what I show you is service model. Now, the good question, why do we need all others? So that's why, let's talk about channel layer. Okay, click here, listen to me. Channel layer is about the full control of communication. Okay, here that's where you're moving from the world of C and you're actually kind of dropping into the world of web services. You actually want to know what is the channel, how do I, what is actually the binding, what is actually the type of the channels, and all the other things. You want to know what is the message, what is the species of data that is sent back and forth. That's why there are two objects, similar to service proxy that I showed you. There's going to be two objects. Messages that represent the data that is sent from one side to another, and channels that actually connection between those two endpoints. And you have the full access to those. Message is actually consists of body and headers, and you get those APIs like get the body, set the body, get the header, set the header. You can set not only SOAP headers, but you can actually set HTTP headers. And actually, this is the HTTP channel, which is helpful in many scenarios. The channel is abstraction of the message exchange. So as I said, this is actually about physical connection. Okay? This is unified API for 3 transports that we support in this version. The HTTP, TCP, UDP. So the only part where you're setting is you're setting the channel property, kind of actually binding, where you're setting that, okay, I'm going to use TCP channel. Okay, all other things is that actually is the same thing. You create it, you open it, you send, receive, you close it, and you delete it. The most interesting part here is the properties, because there is a rich set of properties. And those properties actually help you in terms of the setting all those different parts of the communication. And that's what we actually will look at in the second demo. Because we actually expose the properties of the channel, even in the service model. Because there could be many scenarios where this is helpful. So let's move to the second demo. And let me move back to my laptop. We're looking on a next version of this client that we created. There are 3 things that I've done. 2 things, actually. I copy and paste this routine from the samples. That's called print error. What it does, it gets the properties of the error objects, and it gets the count of the strings that are part of the error objects. And then, in a loop, it just prints those strings. And I will show you the value of this routine right this one. When I run this app, the first build, okay, what do we get? We get an error. What is actually happening in this? Let's kind of look through the error. So as you can see, there is actually kind of like several error strings that actually pump it up. And it says like the format of HTTP request was not supported by the server, but then it says a little bit more. It actually says that there is a status code return, and it says that it cannot process the content type. What basically happens here is mismatch of the binding. I choose the different binding on a client, and that servers didn't like that. Okay, so that's why it says I'm not going to process that. So why did I did this? I did this on purpose because I'm using the manual way of creating proxy, and this one I didn't show you before. As you can see, in a manual way of creating proxy, I need to know things like, what is the channel type? Is this a request? Is this a reply? Is this a duplex session? Is this a one-way session? And many other things. Now, if you know older web services, you probably know what those are. I'm not going to drill into this, but just to get to communicate the point, if you create proxy in a manual way or host in a manual way, you need to know those things. You need to know things like, is that a HTTP channel or not? TCP channel, whatever that is. In this case, I select HTTP channel. But the main thing is that, as you can see, there is a parameters here, channel properties. And because we're using the basic HTTP binding, we default, similar to WCF, we default to HTTP binding, which is based on the newest specs. And in this case, there is a mismatch. We defaulted to HTTP binding, service is expecting HTTP binding. There's a mismatch on the binding, service refused to communicate with this client. So here's the way how we would do this if we continue using the manual way. I'm not going to write this. I will actually copy this. Okay, so this is manual way of filling in the channel properties. As you can see, so basically, let me remove this toolbox window so you can see all of it. The things that I said is that I said, what is the version of the addressing? In this case, actually, it says version in transport. It actually says there is no WS addressing version. It actually relies on the transport. But then there are things like, I said envelope version SOAP 1.1, because basic HTTP is using SOAP 1.1 for the format of the messages. So this is the, if I had to continue with this, what I would do is I will just fill in this property, channel property. Okay, and I would say there are two channel properties. So now if I build it, okay, it works. However, just to going back to our first demo, you do not need to do this. All of this could be replaced, and I will get the toolbox back. I selected all and I deleted it, and here's our template back. And just to make the point, I'll build it, it all works. So what I show you in this demo, I show you that even if I'm using the service proxy, okay, even if I'm using service model APIs, you have the access to the underlying channel that service proxy is going to create to communicate with another party. And you can set the properties in it. Moreover, that's if you can actually go beyond that and you can set what is a channel binding, what is a channel type, and all the other things. And in properties, you can select timeouts and in all other things. There is about 50 different properties on a channel that you can tweak. Things like if you're using the proxy, how you authenticate the proxy, and many other things like that. Okay, so let's go. Actually, we're done with this demo. Let's go back to talk about another important part of the channel layer. Security. Security is important in the world of web services. So the channel layer is actually provides us this granular control over the security settings. Security is about securing the message exchange, the confidentiality, the integrity of the messages, and all of those things. There are usually two modes of the security, and if you're familiar with WCF, you should recognize the names right away. Transport security is about securing the messages during the actual on a wire. This is SSL on HTTP channel, Windows SSPI on a TCP channel. We do not support SSL on TCP channel that WCF supports. And then After that, the next mode is about how the client authenticate, how the client authenticates to the server. That's usually called a mixed mode. Basically, parts of the message security, part of the message will contain some information for the service that helps client to authenticate to the service. Things like username and password. There will be header that is part of the message, like username and password. There is a Kerberos APREG that will also support. This could be XML token. That represents a general kind of blob XML data that servers recognize. Or like secure conversation token. And actually, too, when you establish secure conversation, those of you who know what a secure conversation in the world of web service is about, once you establish the token, you kind of don't need to authenticate client all the time. You just add the token to the messages, and you send them back and forth. And we have a basic support for SAML federation. Now, this is the advanced kind of scenarios of the web services. I'm not going to drill into this. WCF has a very extensive support. We actually have a basic kind of support for it. We actually have customers who are OK with that, and they're using this support. So if that's something that interests you, let's talk after the talk, and I can drill down into details. What we don't support is what is called full message security. This is the mode where transport is unsecure, so basically plain HTTP. But the messages itself are fully encrypted. And they can be preserved and saved and kind of retransmitted and everything. We don't support it primarily because we very closely work with the early adopters, and nobody expressed interest in that mode. And it's very complex to implement, and there's a performance issues around this mode. So we just said, OK, we will stay back until we see customer demand for this mode, and then we'll support it. But that's something that WCF supports. We don't. So why I'm showing this is that basically we will now do the most frequently used scenarios is HTTP with SSL. And that's the third demo. That's what about. So we go and let's switch to the laptop. OK. We actually, in this demo, we actually using the endpoint that, as you can see, located on HTTPS, okay, on this machine. And we actually going to try to connect to it. And another thing is that this is actually WSHTTP binding. So what if I try to run it? Reload it and run it. Again, that's where the errors come handy. That it says that I'm trying to connect to address, which is HTTPS, but I did not provide any security description as a part of my binding. So there is something wrong going on, because that service is not going to accept that kind of communication to me. So what I need to set transport security binding. So basically, I'm going to use SSL binding on HTTP channel. And again, there are two ways of doing this. As I said, manual way of doing this. I'm using the manual way just for the purpose of the demo. And again, I'm not going to write it, just to save the time. Here's this. So basically, this is filling in C structures. But what I basically said is that, OK, I'm going to use WSSL transport security binding. And that's going to be part of the overall structure of the security bindings. There could be several of them. Okay? And I just use one of them. And that's going to be part of my security description. And I will pass my security description into the manual way of creating the proxy. Build it. OK. It works. So what I've done is basically that I just set the right binding on a manual way of creating the proxy. I said, OK, I'm going to use, this is my security description of conversation with a service. Here's I'm going to use, SSL binding. And then it all works, because now binding and matching. Again, you do not need to do that. Right way, select it all, delete it, and use the template. As you can see, WCTL recognized that there is a binding that uses HTTPS and SSL, and this is WS-HTTP binding. And it created helper for us saying that, okay, you're going to use HTTP with SSL. Just to make the point, I will build it, run it, it all works. So that's where we will I will mention when would you need to fill in this structure. This is when you need to provide the client authentication credentials. So for example, if I want the username and a password to be part of the initial message that is sent to the service for authentication purposes, that's where I would fill in this template, this WS-HTTP template. And there are placeholders within it to say, like, okay, this is the username, this is the password, send it to another party. If there is an XML token, same thing. I will get XML token, for example, like a SAML token. I will get that token, I will fill it in, and I will say, this is the token, send it to the service for the client authentication. So that's the place where you would fill it in this structure. Okay, let's go back to the next part. So I show you the security description. Again, this is the element of the channel layer that you can use from the service proxy, from the service model layer. Okay, so we talked about service model. We'll talk about channel layer, XML layer, last layer on the slide. Why do we need XML layer? It's like everything is working. XML layer is about giving the full access to the content of the messages, every part of the message. What is, how it's formatted and everything. You can get, all elements and everything. We're talking about SOAP part of XML, and we have unified APIs for all encoding. Actually, the representation of XML content on the wire. So again, you don't need to. You just set in the property when you create in the channel, when you create in the service proxy, and there is one unified API. They all expect this is XML, no matter if this is a text on a wire, or if this is a binary, or this is the mtom on a wire. We're working with a SOAP subset of XML. So this is not a general purpose XML parser. We do not do DTDs. We do not do processing structures. For the reason is that we want to be highly, well-performed, highly tuned XML parser, and we target it to SOAP XML. So we'll parse the elements that we expect to see in a SOAP message. There are three key objects of XML layer: XML buffer, and XML read and XML write. And they do what actually you can guess from the name. XML buffer is a memory storage for the XML data. So basically, it allocates blob of data on a heap and it puts the data there. XML read and XML writer can work with XML buffer, or they can work with a string. So basically, they will ask you, as they parse, they will ask you, okay, give me more XML data. Or XML writer will say, okay, I wrote this data, give me more. Or XML reader will give you, okay, here's the data I've received, here it is, do something with it. And they're forward access only, so they go through the XML data and you can get one element, then another element, then another element, and they have integrated canonicalization. That's helpful for the scenarios when you do, for example, like XML signature. So we actually got one internal customer who was primarily interested in integrated canonicalization support for that. And they were able to achieve their performance goals just because they were using these APIs. Now, if you I'm not going to drill down to how you using these APIs to format XML. That's actually very straightforward, and it's not that interesting for the majority of you. There is actually a hidden value of XML that we will see everywhere in the framework, and this is serialization. Serialization is about the mapping C data types to XML types. It's about making sure that you work with the C types instead of working with XML, instead of parsing XML. The way how that works is basically there is a one-to-one mapping about the complex types that you expect in a data contract and the C structures and elements. So basically, in this case, in this example, you have a purchase order element that could be part of this is purchase order complex type. It could be part of the SOAP message. And you actually work with a C structure purchase order. And that's where the WSITL comes handy. It generates all those C types for you from the XSD. And the best way to explain it is actually to show it. So that's why we jump into the fourth and the last demo. I will actually show you the value of serialization to you. Let me move to my laptop. Okay, so same thing. We're still on WS HTTP binding. There is no security here. This is what we wrote before. We expected doubles. However, this is a fancy calculator. This is a scientific version of calculator. It takes complex numbers. Okay, so let's look how that modified the contract. I run the WSITL before that on a new set of contracts. And if we looked on the new definition of this method, as you can see, it's using the complex number type. Okay, so what is this? So let's just use the power of IDE. Oops, and it's here. Okay. So as you can see, actually, it switched to another header. It switched to the header that was generated for XSD file, because that's where it defines the contract. And as you can see, it declared for me a structure, complex number with two doubles, real and imaginary. And instead of actually filling now just doubles and actually working with a complex type, creating an XML buffer and populating and filling it, now I'm working with a C structure. Working with a C structure, with the C types, and I will show you how I do that. Let's go back here. And I will actually copy and paste the code. So basically, I will just delete this old way of doing this. And I will just copy and paste the code. Here's how this call is modified. So what I did here is basically this is the same. So N1, N2, a multiplier result. But here, instead of working with the doubles, I'm actually filling in the structure. This is as far as I need to know about, how that is represented on the wire. This is the power of serialization. I just work with C structure, and I'm expecting service model using serialization to format the right XML type and put it in as part of the SOAP message and send it to another site. And well, we want to get the result back, and we want to present it nicely, so we'll just modify this printf. And again, I'm not going to write it. I'm just going to copy and paste that. So that's about it. So same thing. I just I modified it to print out the different parts of the structure, 2 lines. This is basic C, so let's just compile it. To run it, as you can see, 2 complex numbers multiplied, and I get the result back. So this is serialization in action. If there was a more complex type with a more parameter, like there is another classic example from WCF is a stock ticker, okay, or the purchase order. So with different elements. Yeah, it will be the same. Yeah, but there will be strings, for example, maybe part of it, and it will be the same. That's the value of serialization. This is similar to how data contract works in WCF, and actually many other SOAP frameworks provide the same one. But that's the value. That's the value of serialization. That's the XML layer underneath. Now, another thing is that if you will use directly XML layers on XML documents, that's how you actually read in the data from XML document. You tell the XML reader, hey, I want you to read the element from XML document that matches this structure. So you provide the namespace of the element, you provide the structure, XML reader finds that element and populates you the structure and gives you back the structure. Another thing is that I didn't mention that you didn't notice that, is that this is the this is the heap. You see, I did not allocate anything, and I did not actually delete anything. That's the power of the heap. The element was pre-allocated for me on a heap, and it was actually will be released afterward when I will delete the heap, or I can reset the heap. And it helps when you, for example, I wanted to accumulate several results from several calls to service proxy. Because they all will be stored in the heap. They are tied to the lifetime of the heap. Or, for example, I want to keep them longer than service proxy. Because, again, I can keep the heap object longer. Or, like, for example, service proxy can be called from multiple threads. But heap actually is thread specific. So I can provide different heap objects to one call of service proxy and get the data on different threads. So that's the value of the heap. That's great, actually. It's actually a great thing to have when you're using these APIs. And it significantly simplifies this whole programming model with C APIs, because usually with C APIs, you're asked to guess the size of the structure or something like that, or actually you have another API that gives you the size of the structure, then you allocate it, then you pass it to C API, it fills it in, and then you need to deallocate it. So this is much complex and most likely to make an error there than here. Okay, so we're going back to our slides. We talked about all three layers, I think if you have more questions, talk to me. There is actually more details in the backup slides. This slide, I'm not going to talk too much for this slide. This is actually kind of supported configuration. I mentioned that HTTP, TCP, UDP as a supported protocols, text binary, MTOM as a binary, so envelope versions is SOAP 1.2, SOAP 1.2. Security things, that's what I said partial, because those specs actually also include the full message security mode. We don't do that. So how do you get started? PDC built on Windows 7 has the web services DLL in System 32. This is the runtime component that actually you're using when you're using these APIs. PDC built on Windows SDK has the tool wctl.exe, has the header libraries, has a preliminary build of documentation. It's very detailed. It goes and talks about every function. It's up to date. Every function, every structure, every kind of scenarios, channel layer, and everything. It's a great documentation. And we have 92 samples for pretty much everything, every part of the APIs, client and servers. Now, if you're interested in XP Vista 2003-2008, just as I said before, please wait for the system update. We will try to have it shortly after Windows 7 beta. And shortly, I mean like, well, I think within a month we'll try to have. But I will have some links on the blogs and the news groups. Just monitor those, and I will let you know when our system data is ready and available and where it is available. Additional resources. You will have the access to the slide deck. If not, I will put it on my blog. There's about 20 slides as a backup slides that talk about, again, details about every element. Something that I cannot cover in 1 hour talk. There are related talks. There is a hands-on lab. Hands-on lab is actually you modify an existing MFC application. You don't need to know much about MFC, but you only need to know about Web Services API and that demo, hands-on lab. But you modified it to talk to live search service, which is ASP.NET based service. I didn't show ASP.NET XML service as part of the talk. Just that's where you actually try it in a part of the hands-on lab. And actually it has this advanced serialization. You ask to fill in this structure, with like 10 elements. And you can see, okay, how that looks. So there are strings and everything. So you can actually try and you get the same structure back. You can kind of practice your skills with how you parse that and how that looks. And I mentioned that building with MFC. That's actually helpful for the hands-on lab. That's actually the talk, I think, next talk. Because I'm using in hands-on lab the SP1 version, Windows Visual Studio 2000 SP1 version of MFC that has all the advanced look. You're working, during the hands-on lab, you're working on a application that is very similar to Microsoft Money. It actually looks this as Microsoft Money and kind of does things as Microsoft Money. And you're working on one part of that application. So if you don't know MFC, the next talk actually will talk about those parts of that. This is the additional kind of resources container. We have the developer center for the whole networking group. And there is a Connect site for early feedback. There are blogs that I mentioned. And there is my email there also. I just want to say thank you. I know this is a very early talk, so I greatly appreciate the attendance. Thank you very much for coming to the talk. And that's it. I think we have about 10 minutes for the questions. So. Thank you. I think there are microphones. Support config slide back. OK. 1, 2, 3, 4. OK. Yes. Please use the microphone so people on the recording can hear you also.
Question here, Nicola.
Yes.
You were talking about the
microphone.
Sorry. You were talking about the translation from the XSD over to a C structure. How do you capture, let's say, format strings describing the string representation of, let's say, a date timestamp? How do you translate that into C structure? And then also, because sometimes in XSD, the provider could specify that this is a timestamp, but I need it in this sort of textual format, right? So you get that from your, how do you call it, WSDL analysis.
Yeah,
you generate your C structure. And how do you capture that so that in C you work with whatever the datetime type is, and then when you ship it over, your SOAP data actually conforms to what the server needs? So,
so data type. So there are two parts of the question. One is a string and one is a data type specifically. So the strings will be WHR stars. So, okay, so they will be part of the data type specifically. If this is, I actually, from the top of my head, I don't remember how it's represented in XML schema. So I can check for you afterwards. But if it is a string, then it will be WHR string. We're not going to do any kind of runtime verification whether you filled in the right format of this, that element.
Sorry, let me clarify. With timestamp, what I mean is you get a timestamp object in binary, whatever in memory the current time is. But on the server side, let's say it's European, they expect day first, dash, or whatever, a month.
Yeah.
That's sort of what I'm talking about in terms of the format string. And how do we, and let's say we're in North America, and ours is month first, day first in textual format for timestamp, right? So when we send that out, serialize that out, how do we ensure that it's correct for the server side?
So the question, let me put it this way. So I'm pretty sure there's going to be a string that you will be filling in your in your code, and then the service is going to reject it if this is not the right format. That you will get back a SOAP fault. Now, if there is actually element, I just don't remember data type element of XML schema from the top of my head. But if it says let's say this is the complex type, this has day time, daytime in months, then we will give you those elements and we will format them for you according to the schema. But if this is actually a string, that sounds like what you're saying, and actually this is a string on a wire, then it's up to you to fill it in correctly. And if you don't, then you will get the SOAP fault from the server saying okay, this is not the right format, fill it in. Okay. But I don't think, we don't do any kind of runtime verification of that, whether that element is the correct in terms of the, we will do the verification whether it's correct in terms of the schema, but whether the service is expecting this element as it is, as a documented or something like that. No, we don't do any kind of verification for that. But let's maybe sync up after the talk, and I want to kind of drill down into your scenario specifically and look what is going on.
All right, thanks.
Over here. Is there a way to reuse your WCF configuration in XML and bring that into this API?
WCF configuration. Well, it's a good question. What do you mean by reuse? Could you clarify what do you mean? Like, I mean, we don't. Let me give you a quick answer. Okay, we don't support configuration. We don't have anything like configuration in this release. Now, what do you mean by reuse?
Well, I would love it if I could just take the WCF configuration that I have for my full-blown C++ server and use it on a test server that is managed code. That's a stub-out implementation of test clients, for example.
I see. No, we don't do that. We don't have any support for the configuration files. It sounds like what you're looking at is just reuse basically web config from WCF when you populate in the services based on these APIs. No, we don't have that. It's a good point, actually. We'll look into this. This side?
Do you support signing and signing of the checking of the signing in XML reader and writer?
Yes. Yes. Yes, we do.
So in .NET we have this XSD tool and then XML serializer, and I saw the XML serializer also being part of the XML layer over here. So if I'm not using WSUtil, is there any plan for having any tool which will generate the C types for the XML data, and can I use the XML serializer in the native code the way I use it in the managed code?
So let me make sure I get your question right. You want to, there is XML serializer in .NET Framework, okay, and it works on general XML document, yeah? And you will get the .NET types after that, yeah?
Yeah.
So you want to, so that's pretty much what we, that's what XML reader and XML writer do.
Yeah, so
for
is
you.
there any similar tool like we have in the .NET, like XSD tool is there in the .NET?
Yeah, so this is WSUtil tool. The WSUtil tool will go through the XSD for that XML document, and it will generate you the header with the serialization structures.
Even if I don't have any WSDL to supply to
No, yes. You don't need WSDL file. You just need, if you have just XSD file, it will go through XSD file. It will generate you the C structures that map to the types that are part of the XML. And then you can use XML reader or XML writer to get the data from XML document that matches to that XML scheme.
Perfect, thanks.
That side, no? Okay. Yeah.
So with the XML signature support, what all does the web services support there? What are you looking for, I guess? Well, so we've had to do this, of course, all manually now, and we've had a lot of issues with encoding and things like that. So that'll help us a ton with the canonicalization and things. But does it support doing XML signatures?
I'm not sure in what extent you're asking that, what extent of support you need. We have basic support, and okay. I'm not sure if that matches what you need. So we probably better, kind of, if you can give me a specific, like, what are you interested in, and like, then I can talk to see if that's what it matches to your needs.
Okay. Thanks.
XML signature. There is another. So yeah, I'm not sure if you know. There is another library part of Windows 7 called CryptoXML. That actually works specifically and only on XML documents, and only with XML signature and how you write. So maybe that sounds like something that if that's the only scenario you need, that most likely the library that you want to use.
Okay, I'll take a look at that. Thank you.
Two quick ones. Well, one of them really quick. Will there be a redist, or is it Windows Update only for the XP Vista?
Now, so I understand that reduce is very important, and I actually talked to several legal people about this, and there are actually, any Windows update can be redistributed. So there is actually a whole process for enabling any Windows update is redistributable. Now, I think it's too early to say about details, but I do recognize that that's an important problem. That's what many people want to do. So most likely, like my personal promise I can give you, so I will be working very hard to make sure that there is some kind of very well-established process for people who wants to redistribute this Windows update. And as I get closer to the details, I will make sure that you guys know what that exactly. Because even just to tell it, so what most likely this is going to be update download from Download Center, like all other things. That's usually an end-user download. Okay, but there is actually the ways, and I've done it before, that you attach a redistribution license to it, and then you can redistribute it. That could be one way. Another way could be a special agreement with Microsoft, between your company and Microsoft, and that you actually redistribute it. So it's too early to say. So when we get to the beta, that will be actually to RC, or to release candidate. That's more likely when, so basically, next kind of spring, when that's most likely when we will be talking specifically about redistribution, how you do this, and how to make sure that external companies have an easy way to enable this here.
Okay, and quickly, this does server side as well, not just client.
Say it again?
We can do server side. We can do
yes, yes, absolutely. You can do the server side. I just didn't show that in the demo.
How are they hosted?
What? Self-hosted, yes.
So, scalability-wise, you're not going to get. Is there any idea of what it's going to be like for?
We run in very heavy stress scenarios and long haul scenarios. So we haven't seen any problems. If we see any performance or kind of scalability issues, we fix them right away. Internally, we make sure that it's scalable. So.
Okay, thanks.
Yeah, this side.
I guess following up with that, is there any thoughts or plans to leverage IIS from a hosting environment for native code?
IIS hosting environment. That's a good question. We haven't looked into this in many details yet. You can probably do the right way of doing this, but we haven't looked into this.
Okay. Another question is, have you thought much about doing a template or C++ wrapper on this, and either through a shared source type model or feature framework extension?
Yeah. I actually expected that to be one of the first questions. But yes, we did look. We actually, some of you know that I actually came from C++ team. So I work on ATL proxy and C++ libraries. So we did talk a lot about this, and the kind of we agree that we want to see if that's going to become on demand. But so far, yes, that's about third or fourth question on gate. Like, what about C++? We actually saw one of our internal customers starting coming up with C++ programming model. So we will see. We will, for Windows 7, probably not. It's going to be flat C APIs. But that could probably be a collaboration project between Visual Studio and us, making sure that maybe there's going to be good C++ model. Because I can definitely see how C++ would help with some of the things, like with stream proxy, with closing. Another thing we saw, we saw one implementation when people tried to create service proxy in a constructor, and that's just wrong, because you can get some assertions from that, and then you kind of really broke it. So creating service proxy in a constructor, that's definitely not something that we want people to see doing. But we'll look into this. We'll look into it.
Hi. So do you have any examples in bits how to expose service, not just consume it?
Yes, about 50 of them.
Okay, thank you.
There's actually going to be there's going to be an MSDN code gallery. It's either already online, or I will make sure that it's I have a link from my blog to it. It's going to be very basic kind of same service, just re-implemented on the server side. But overall, if you look on Windows SDK documentation, there's about, as I said, about 46 exactly samples of server side, and they will take more time if I would do this during the talk, because you need to implement callbacks, you need to say where's my metadata, and so they would take a little bit more time. That's why I didn't show them.
Thank you.
No problem. Yeah. So my hash is right. Here's, oops, I'm going the wrong direction. Come on. Yes. So that's the links to the blogs. So the first blog is my blog. The second blog is how this actually interop expert on our team. He's going to all the blog fests. He knows everything about interop. With WCF and all the other third-party there's going to be a basic profile event going on after, and I think in 2 weeks he will do remote testing with other vendors around the basic profiles. And the third one is WNDP. This is the networking kind of for developers blog. It has everything about Windows HTTP, WinSock, and there's going to be parts of it. There will be at least links to the other blogs. And one of the things, the Networking Developer Center, there is actually a very nice RSS feed aggregator. So as we get many more blogs from my team or from evangelists or from other people around the world who blog in on these APIs, we'll make sure those are kind of aggregated and presented and announced on that page. Any more questions? Thank you, guys.